Damn it, Jeff. This is so fundamental. You little... Let me try to do a recap. Hello. So, in these problems, these are called optimization problems. Can you see why this is called optimization? Largest. Like I want to maximize my profit. I want to minimize my cost. I want to whatever. Yes? Those are optimization. I want an optimal situation. And graphically, optimal situations are most often that one or that one, depending on if big or small is good. So they're going to tell me something. I write a formula for it, in which case I have chosen my variables. They cannot change now. Then I write, using the same variables, a relationship related to what they ask me. Now, if this is related to the derivative, and this is the function I want to take the derivative of, because what do I want to find the maximum of? The product. So I want to take the derivative of P. Are you guys with me? So if the problem says, like, find the maximum profit, what function do you need to create? Profit function, because then I can take a derivative, set it equal to 0, blah, blah, blah. You with me? Does that make sense? Okay, maybe. So what is wrong with this at the moment? If I want to take this guy's derivative, what's wrong with it? We're used to this. Huh? The number of variables is too damn high. Thank you. Got to get that meme in there. Okay. So can I use what they tell me to help decrease the number of variables here? What could I do here?
You could either solve like x in terms of y or y in terms of x.
Holy shit. And then paralysis of choice. So it doesn't matter worth anything. Now, sometimes it might, but this is pretty symmetric. Sometimes one letter might be better to solve for than another. But in this case it is. So what do you guys want to solve for? Because I want to know. Oh, yeah. Oh, so y equals what? 10 minus x. So now I know this is true. So how can I rewrite the product function?
You could substitute the 10 minus x into y.
Good. And then if I multiply that through, I get this. And then what did we just say a minute ago we wanted to do with this? Take the derivative. All right, what do you get when you take a derivative? 10 minus 2x. Is that ever undefined? No. Is it ever equal to 0? Yes. When is equal to 0?
X is
5. If x is 5, what's y?
y is 5.
Y is 5. And then what's the product then? 25. Now real quick, just to kind of check this out. Can you give me 2 other numbers that add to be 10? And what's 4 times 6? Which is less than that. Now that's not a proof, but that's a really quick check to make sure that it makes sense. 25 is your highest, we'll just pick something else close to what you got and see if it comes out lower. And if it does, you're like, feel better about that. Now real quick, this relates to the fact that if I want to maximize the area of a quadrilateral, it's going to be a freaking square. Does anyone see how this relates to that? What's the area of a rectangle? Length times width. So it's basically x times y. So if I want the biggest area for some given perimeter, I'm going to make a square. Does that make sense? Sort of. Well, you'll see that. I'll point it out. This really. So let me give you this. Let me save you from my writing, at least for a moment. How much do I want to do anything before this? No. So I have one side of this has worked out examples. On the other side, we're going to do it together. And then I have another worksheet I'm going to make you do by yourselves. I know. And you could read it. think that's everybody, yes? I don't remember when I kind of realized the way that I do these problems. I basically do tell me, ask me. One of the biggest things about how I teach mathematics is it's sort of like if you're a really good artist, you were kind of born with a predisposition to see something or something. You were born with some kind of immediate ability that goes right into that. I'm good at math, and one reason I think that is because I was just born with this ability to break shit down. And I can focus on parts, yes. Not everybody has that. I can't draw more shit, so if you can draw, good for you. So, I kind of did this, and then I just realized what I did, and I gave it a name, and now I try to make it the way I teach this. Tell me, ask me. It's really silly how every problem just about breaks down like this. So let's read this. We're creating a bunch of rectangles, and the area is always 25 square inches. Find the smallest perimeter for such a rectangle. So this is the kind of problem you're going to get. Do you guys see how there's two ideas? One idea is related to area. One idea is related to perimeter. So those two ideas are going to go into tell me, ask me. Which idea do they just straight up tell me? And of course you can read it, but they just straight up tell me the area is 25 square inches, yes? What I have to choose now is variables. So what you really should do is draw a picture and choose variables. In this case, I chose L and W because my creativity knows no bounds. You can choose X and Y, you can choose Greek letters, you can whatever. So what do they tell us? The area, and since I chose L and W, my formula for that is 25 equals LW. So I can set up a relationship between all the variables based on what they tell us. What do they ask us about? Perimeter. I can set up a formula based on the variables I chose that relates to perimeter. And this is one perimeter you guys very often have memorized, and you shouldn't memorize any perimeter because it's just add all the sides. So you get two L's and two numbers. Yes. And then you can see how the number of variables in that, because what am I trying to get again? What's the main thing I'm trying to get in this problem? Smallest perimeter. So have I created a perimeter function?
Yeah.
Yes. So I want to take its derivative, and I don't want to do it the way it is, because there's too many damn variables in there. So if I use what they tell me, this, I can solve for a letter I chose to solve for L, in which case I can take this and put it in place of L. Now do I have an equation that has just one letter in it? Just one letter. Okay.
Yes.
Good. And I really want you to see why that's so important. Do you see how I can now do a derivative with respect to W? But if I had both W and L, I cannot do a derivative with respect to both things at once. That is the reason I want to decrease the number of variables. That is the reason they must tell me something, so I know how the variables interact. Yes?
Can you take the derivative with respect to two variables at the same time in later math?
Hell yeah. In fact, it's the whole point of math, Calc 3. Calc 3's name is multivariable calculus, yes. And that's where you do stuff like partial differentiation. That's way off in the future. You guys kind of, this one's not too intensive. If I plug 25 over W in, I get this 50 over W plus 2W. If I then take this guy's derivative, I get here. Now, when is this undefined? I should have put this down here. When is this undefined? If W is 0. Does W equal 0 make sense in the problem? If I make the width 0, what's my area? 0, yes? That's obviously not a valid answer. I want I want the smallest perimeter. Okay. So what, let me see, there we go. So if I put it in, and I take a derivative, I eventually get to here. And if you were paying attention earlier, that makes sense because what does the width of 5 lead to? If the width is 5, then the length is 5, and that's a square. So very often the optimal quadrilateral will almost always be a square. Unless you have a river on one side and it's only 3 sides that you have to construct or whatever. Yes? Okay, how's everybody feeling so far? Now, one little thing I want you to note is here, what the hell is this all about? Second derivative. And since it's concave up, always, that means that what I found was truly a minimum. Yes? Maybe. So I found the minimum, I found the width that leads to a minimum perimeter. So what is the perimeter then? Well, I got a formula. If I know W, I know P. If I just plug a 5 in, I get 10 plus 10, I get 20 inches from my perimeter. Okay. Do you guys see the flow of almost every problem is going to be like this? Tell me, ask me, use what they tell me to help rewrite what they ask me, derivative, solve. We have another example that's a little more involved down here. I really wanted to make sure to give you one of these examples because you're going to see these in the book. I'm going to construct a box. So I've got laying out on the ground, I've got so much cardboard or whatever the hell I'm going to make this box out of. Yes? So I've got a total amount of 1,200 square centimeters of material to work with. So I can bend it, fold it, and whatever to make this box. So I'm curious, I'm like, okay, what's the largest box I could possibly make? Yes? Just straight up the largest box. Why would that make sense?
Because you want a big box.
Because you want a big box? Because if I can produce multiples of these boxes and I can use the least amount of materials to get the biggest volume, then overall I'm going to be saving a lot of money compared to making a bunch of these goofy little boxes. Okay, maybe. Huh? Yes. Gather stocks, something, profit. Okay, so what do they tell us here? The surface area. Now this is where students trip up because you're not used to working with surface area. Why did I make my picture the way I did? Number one, it's a box. That's a good thing. But what else did I tell you? What's true about this box? Square base. So whatever letter I use for one of the sides of the base, better be the same for the other one, yes? Now I don't get this a lot, but make sure if you call two things X that they really are supposed to be equal. Sometimes I get a student just call everything X that they don't know. I'm like, well, you're assuming they're equal. If they're not supposed to be equal, they have to each get their own letter. And then you hope that they're related somehow. And of course the height can be whatever the hell it wants to be. So I've got to call it H. Okay. Blah, 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 blah. So here's the trick. This is nothing you have to memorize. This is nothing you have to memorize. What else do I know about the box construction? I wanted to have a open top box. So if I draw in, surface area is sort of like perimeter. You just add up all the freaking areas. So I've got one side that has an area of what? X squared, because the other one is open, yes? And then how big is every side around? What's the area of every side around? X times H. And how many of those do I have? So I got 1x squared and 4 xh's. Is that cool? That's not a formula I had to memorize or any shit. Trust me, I don't. I only have so much space left in my brain. I want to forget where I live. If I memorize something else, that's going to go. You guys kind of with me? So it's not a formula you have to memorize. It's a formula you can very easily construct. Whenever you need it, you can just do it. So they just told me the surface area is 1,200. So now I can say the formula for the surface area using the variables I chose is 1,200. So I know that relationship between X and H. What do they ask me for? Volume. And what's the volume of the box? It's going to be the area of the base times the height, right? So that's x squared h. So now I use what they told me. Now let me ask you this. I know you have your own page. This is only going to do so much. Which letter, x or h, would you rather solve for in this? H, all day H. If I wanted to solve for x, I'd have to do quadratic formula. Screw that shit. Do you see how easy it is to get h by itself? Why is it harder to get x by itself? Can you put every term with an x in it, can you put them together? Can you add them? Every term that has an x in it? No, because they're not like terms. So x is in multiple places with different degrees. Screw x. Do you see what I mean? So the first problem was you could choose L or W. I don't give a shit. I just happen to choose L. I could have chose either one. It doesn't really matter. Here, I'm going to freaking solve for h. Holy shit. You guys follow? So if you start to solve for a letter and you're like, this sucks, well, go back and try to solve for the other letter. Doesn't matter. Okay, so I solved for h. I did it a little quickly, and I'm sorry. How the hell did I get here? How do I solve for h? Subtract x squared, then divide by 4x. That's all I did. Yes? So now I know h is this business. And it makes sense. If I only have so much material and I make this side longer, which means that side's longer, can it be as tall as it used to be? No, it's going to be shorter now. So h, it makes sense that it's a subtraction depending on x and division. If I make x bigger, h is going to have to be smaller because I only have so much freaking cardboard laying around. Okay. All right. So if I plug that in, if I take what they told me and solve for a letter and make it look even better here, ooh, look at me go. I just divided, yes? And I plug that shit in to the function I actually have to work with. I want to maximize the volume, so I need a volume formula that has one variable it's dependent on. So now I have a volume formula that's only dependent on x, right? And then I distribute, make it look all pretty. You guys kind of with me? Once I'm there, once I have the formula that is related to the thing I'm trying to make the biggest or the smallest, and it has one variable, I just calculus. Calculus takes over. How do I maximize this? Take the derivative, see where it's undefined, or 0. Yes? You guys okay? So then if I take a derivative, I get 300 minus, boom, 3/4 x squared. I could take a 3/4 out. You could do this a few different ways, and you eventually get x squared equals 400, so x is 20. How do you figure out the, yeah, good.
So if you got multiple x's, you could just compare the two and see which one's like the minimum or maximum?
It is possible. So for example, you could have a more complicated problem based on the one we did first. So it's possible to get like L is 10 or 5, and then W is 5 or 10. And one reason why you might get multiple answers is because they're kind of interchangeable. See what I mean? Or it is possible to have a situation where you do have two local maxes. So then you could see which one's actually higher.
Yeah.
Yeah. So if I have a company, this happens very often in the real world. I plot our profit function and I get something like this. Where do we want to be? There. What if that's like not possible for us to get to? Then I want to be here. Yes? Or maybe as far up this slope as I can get. Do you guys see what I mean? So depending on the function you're looking at, there could be multiple local maxes, and then you can just see which one can we get to versus which one is higher and all of it. You guys, yeah, I'm so happy I don't do that as a living. Well, my friend Sean, he was a financial analyst and he made a lot of money, but he also had 5 kids, so sort of all average out. Let me see, blah, blah, blah. What am I doing here again? Second derivative, so I can make sure that it's a maximum. Since the second derivative is negative, what's it looking like as it goes through it? Come down, so it's going through it like this, so there must be a location of the maximum. And again, if you want to, if x is 20, that means that this side is 20 and this side is 20. How do I figure out what h is? If I wanted to know what h was, how would I figure out? I've got an h function right there, right? Or here. So I can just plug a 20 in and see what h is. And down here, I just throw my x into my volume formula, and then I can get what the volume is. So that's the largest volume. How you guys doing? Yes?
So then what would be the difference in setting up the equation if you're looking for the maximum or minimum? Is there any difference between the two?
No.
Okay.
All right. Given the situation, you're going to be able to find an max or min. So they're going to ask you the one that makes more sense. What will it look like? Same damn thing. It's just the function's going to look the same, but it's either going to do this and you have a min, or it's going to do that and you have a max. Yeah. Nothing about your work is going to change. Okay. So let's look at the other side of this. Let's do these together, and then I'll hit you up with stuff to try on your own. This is one of my favorite problems. Not just because I made it up. I did this. So read through it, and then I want to ask you one crucial question. What is your quest? There's a lot of shit in there, yes? There's a lot going on here. You guys with me? Can somebody tell me okay, here's the one important question, and then I'll ask several more. What kind of function do we eventually need to get to? I want a function that represents what? There's a lot going on in there, yes? It's all going to funnel to where I need to create a function that represents what? What am I trying to optimize? Trying to minimize the cost, yes. Okay. Does that really help me right now? No. But I want to kind of be focused from the beginning. If I don't end up with a cost function before I do calculus, I'm doing it wrong. How do I minimize the cost? I take the derivative of the cost function. I don't have a cost function. Oh, I got to make a cost function. Do you guys kind of with me? That doesn't help me figure out how to do it, but it tells me what I'm trying to do, yes? So now I can focus everything on, I know at the end I need a function that represents the cost. So a mistake students make when they get a problem like this is they'll set up the perimeter and they'll do calculus to that. And I'm like, that's not going to minimize my cost. It's going to minimize that perimeter. But why doesn't that necessarily minimize my cost? Because one damn side is more expensive. So I don't want a square. I want to somehow make that side less. And why is one side more expensive, Jeff? Tell me the physical situation. I don't know. I'm going to buy 60 cantaloupes. No, one side is outward facing to the street, and I want it to be able to withstand damage of stuff. There. Okay. Two parties. So I mean, all I gotta do, yes? What variables do you guys want to use? It's totally up to you. That's craziness. So I'm gonna call this X, I'm gonna call this Y. So what's the area? That's insane. And what do we know the area is?
180 square feet.
Okay, so that's the formula for what they just straight up told me. They just straight up told me the area. I'm like, thank you. You're the real MVP. X, Y is 1A. So that is my tell me formula. And more mathematically, that gives me a relationship between the variables. here's where things get exciting. Write the cost as a function of length and width. So there's a lot in that little tiny sentence. Does it matter which side we make the more expensive side? You might be like, how do I answer that question? Well, you answer the question because did I tell you? It does not matter. I need you to understand. So what if I call this the more expensive side, but it should be the shorter side? Well, then X is going to be smaller than Y. You guys see what I'm saying? I need you to understand what I'm saying. Just because I drew my picture like that doesn't mean X has to be longer than Y. It's just a visual anchor for shift. The math is going to tell me, oh, because of these restrictions, this side's got to be longer, whatever. You guys kind of with me? So for our work, let's all make it the same side, just so we can all kind of go through this the same way. But it doesn't matter, we're shit. It doesn't. The math will work out in the end. And by the way, just to be really careful with these kind of problems, you should really label all the way around. So let's say this little dude, this little weird dude, I'm going to say that's the expensive side. Just to show you at the end. You guys should probably realize, it's probably going to be a shorter side, but I just want to show you at the end how it's going to happen. So let me ask you this. Just for the side I circled, how much total money would it cost? What does X represent, by the way? Let's start there. What is X representing? The length in feet. So we're assuming it's feet because that's the units we're working in. So how much total cost would it take to fence that length? 15x. If that was 2 feet long, it would cost 15 times 2, $30, yes? You could do exactly what I just did. Anytime you have a variable, replace it with a nice number, see what your brain does, and then do the same shit to the variable. So if that was 10 foot long, it would be $15 per foot. Oh, 15 times 10. Oh, so it's X, so it's 15 times X. So I'm going to collect my cost, yes? I'm going to collect it. Cost equals, okay, this side is 15X. How about this side? 10Y. How about this side?
10x.
10X. How about this side? 10Y. So what do I end up with?
30x plus
Here.
35.
25X plus 21. Is that okay? Sure. Whatever, Jeff. Ain't no way in hell I know ahead of time it's supposed to look like that. Necessarily, right? You just get there. You guys see what I did, though. Now, I know I said write the cost as a function of length and width. Do you think I'm always going to ask that question there, or am I just going to say find the minimum cost and then you're going to have to do it? So on that step, that's why it's important to know ahead of time, what function am I eventually going to try to construct? A cost function. That'll keep you focused. At some point, you got to be writing C equals stuff, or else you're never going to get to the answer. Okay. Now we do, so now I got my tell me, and I got my ask me. Yes? Can you use what they told me to help rewrite what they asked me? So let's all do the same thing. So the first letter right here we're going to do. What do you want to solve this for? Because I want to know. Oh, so y equals, how do you solve this for y? Divide by x. So this is what they tell us. I'm going to use it in what they ask us. Oh, what did I say here? Solve the area equation. I was very specific. Did we do that? Did I solve it for the length? Oh, screw past Jeff. Everybody go, past Jeff, you suck. We'll solve for whatever we want to. And they told us, this is what they tell us, and I'm going to use it in what they ask us. They ask us the cost. So now I can replace y with 180 over x. Yes? You guys kind of with me? So it'll be 25x plus 20 times 180 over x, and I can make that 25x plus 3600 over x. So right there, I'm simplifying my function before I try to take the derivative, because I know I'm about to do that. Why is that cost function better than what we had in part B? It looks worse to me. Look at that, it's over. Why is it better? Only one variable. I don't care what was going on in the first one, that is better. One less thing I don't know. That's all. That's what I'm trying to do in life all the time. So now I take this. If I rewrite it even better, I can then take its derivative easy. I just take this guy's derivative. 25. Good. Minus, that comes down. X to the -2. Good. So if I rewrite this a little bit, it'd be 25 minus 3600 over x squared. When is this undefined? And that would be dumb. If I make one side 0, then I got nothing I can fit in between. I just have these two walls right next to each other. And I can't slide a piece of paper in there.
I'm gonna put all my papers right.
Doesn't really help. So I don't want to, is everybody with me? It is undefined as 0. But 0 leads to a physically stupid situation, so I'm not going to use it. So what else do I have to do with this then? See where it's equal to 0. So I set that equal to 0. All right, now I desperately want you guys to do. Almost every problem is going to work just like this. These kind of steps. So if I set this equal to 0, what the hell do I do with this? What the shit, Jeff? Calc is hard enough. Look at you. This math boy, give me all this shit. What do I do with that? Huh? Oh, I kind of love that. You could totally factor it the way it is right now, but would anybody else would like to make it look better? Yeah. So, special place in my heart for the factoring suggestion.
Multiply by x squared.
Yeah, I can multiply by x squared, right? Because what's the worst part about this besides the fact that it exists? Poor little guy. It's got a fraction in it, yes? And it's in an equation, correct? If fractions are in an equation, I could kill them. So if I multiply everything by x squared, die. So I get 25x squared minus 3600 equals 0. I'm just going to do it. Add 3600 over, divide by 25. Oh, what would that be? 144. Just 144? Yes. The 2 zeros go away. Yes. 144. And then what do I get for x? Yeah, plus or minus 12, but we know it can't be negative, so it's 12. Is that cool? I don't put the negative, even though mathematically it's correct. Physically, it's not. Because this is supposed to be a side length. And please don't construct anything with a negative side length. Little black hole, you'll suck the whole neighborhood in. It'll be a bad day. So did we answer the question? Here's the last step. I can't remember if I put that on that list. Do all the work, and at the end, make sure you answer the question. What was the question? Oh shit, have we done that yet? What is this, by the way? 12 what? 12 sheep? 12 feet? Okay. So how do I answer the question? Minimum cost. If I only had a cost function.
You can define y.
Do I? Do I need to? If I wanted to, could I? How are x and y related? Right here. So let's see, let's do this completely. X is 12. What's y? 12 feet. Y would be 180 divided by 12. 15. How do I get the cost? Do I have a cost function? Like right above. And do I know what x is? Yeah. 12 times 25 is 3 times 100 is 300 plus 300 is $600. So the minimum cost is $600. Did we end up with a square? What was the dimensions?
12 by 15.
12 by 15. Is that a square? Does everybody understand the problem's done? We over-answer here. Look at us go. We kick ass. I'm going to push ahead a little bit more. There is a square here. Everything I'm about to say, you never have to worry about. So some of you guys can zone out. I saw somebody in the back was like, oh my God. So we just got this, right? Let me see. Let me remind myself. Y was 15, X was 12 feet. This was the more expensive one, yes? So if I want to get the money, this would be 12 times, I think it was 15, right? So how much money did this side cost? 180, yes? Is everybody with me? Sort of? Or how many of you guys have two down? Every other side was $10 each, yes? So this would be 120, this would be 150, this would be 150. Can you guys tell me how much total cost for the things running this way? For the sides running this way, how much total money? $300. How much total money for the sides running this way? There's your square. Your square ended up being in the money. How important is everything I just said not? As a math person, I find that deeply satisfying. I can't remember when I first noticed this, but it was really exciting when I did. So the answer is always a square. It's just not always physically a square. Sometimes it's like, in this case, cost-wise, it's a square. I'll stop, because that doesn't matter to you guys. It's fine. It doesn't help your urge. So, this is one major kind of problem you're going to see. Very geometric. You're going to have different shapes potentially that kind of run this kind of same kind of way. I like this idea. I put the cost as an extra physical idea on top of it. So read through number 2. And what I should do is, here, I'm going to ask you a prerequisite style question. You guys remember how to get the distance between points? So for example, those 2 points. Does anyone remember how to get the distance between those points? If they were across from each other, that would kick ass, because I go 1, 2, 3. If they're diagonal from each other, that sucks major. But what shape have I made? Triangle. So does anyone remember the distance formula?
Square root.
Yes, big ass square root. And by the way, real quick, here's one point, here's another point. This is the difference in the x's, this is the difference in the y's, and this is the distance I want, yes? So let's do this. D squared would equal the difference in the x's squared plus the difference in the y squared. Since I'm squaring, it doesn't matter which way I subtract. Now, I could take a big ass square root, and that's how I'd get the actual distance. You with me? Let me see if you can. All right. So remember that? Do you guys remember this? But it's just Pythagorean theorem. So what sucks about the problem I've given you here? How many points did I give you? Infinite. I love that just happened. Somebody said I gave them 1 point, which is true in a certain way. Somebody else said I gave you an infinite number of points, which is also true at the same time, which is neat. Because how many points are on x squared minus 1? Infinite number. So I want the distance between any point on that line and 2 negative. Can somebody give me every point that's on that line? I'm sorry, on the curve. Give me, okay, I love it. You're all like, come on, man. What do you mean? I can't give you, what the shit? I'm this close to just walking out. Saying, screw this place. Sorry. So here's what I mean. I'm going to give you every input that I could put in. You ready? Here it is. Here's every input I can put in. There. What is every output that I get out? I like it. Which is actually what? What is the output? If I put an x in, what output do I actually get? Y is a representation of it. What output do I get out? X squared minus 1. If you put a 3 in, aren't you going to get 3 squared minus 1 out? Yes? If you put a 7 in, you're going to get 7 squared minus 1. So if you put an x in, you're going to get x squared minus 1. I want you to realize that thing I just wrote, x comma x squared minus 1, is every point on that curve. Can you find the distance between, I'm gonna pretend like it's 1 point. Can you find the distance between this point and that point? In fact, the distance squared, just like we did a minute ago with numbers. Try it, and then I'll come in and do it with you. There's at least one problem in the homework like this, and not two. I do kind of like this kind of problem, so, you know, I might put it on something. So I'm going to put this down here just because I didn't really give myself much room. So here's how I always do it. I need the distance between the x's, yes? And how do you write that? Yeah. And I need the difference between the y's. X squared minus 1 minus x squared minus 1 minus negative 1. Good. So we get x minus 2 squared plus x squared. Do you see that, everybody? X squared squared, I should say. Because the negative 1 minus negative 1, negative 1 plus 1 cancels. Now, to get the actual distance, I would take a big ass square root. Do you want to take the derivative of big ass square root with shit inside? No. Do you all agree with me that if I make the squared distance as small as possible, I am at the same time making the distance as small as possible? If you make the square of a number as small as it can be, if you square root it, you get the actual smallest number. Does that make sense? Okay. Maybe. I need this to make sense. To get the actual distance, I have to square root. Calculus would suck. It would still work, but good God, it would suck so freaking bad. I have to realize the calculus, if I make the square distance small, the smallest, I've solved the distance the smallest. I've done both at the same time. And what would it be like taking calculus of this, doing the derivative of this? Well, that would kick so much ass. It's just a stupid polynomial, yeah? No offense, you're awesome. So if you wanted to, you could FOIL this out. I'm not going to. I'm going to do this. And then I'm going to do this. What's the derivative of this? 2 times x minus 2 plus 4x cubed. So we get 4x cubed plus 2x minus 4. Is that ever undefined? No. Is it easy to set equal to 0 and solve? What sucks about trying to set that equal to 0? What power is kind of wrong? The third power. Well, it's too bad for us is what we got. So, just to let you in on my head right now, I'm like, what did past Jeff want to do with this? I think past Jeff wanted to do synthetic division. So let's see. If I set this equal to 0, and why am I doing that again? Because what step of the process am I at now? Trying to minimize the distance, right? So I'm going to take the derivative and set it equal to 0. So that's what we're doing right now. I got the distance formula set up. It's distance squared, but we're cool with that. If I take the derivative set equal to 0, I can see where the extreme I have. What can I divide by just to make this?
2.
Yeah. So that'll be 2x cubed plus x minus 2 equals 0. as we do this. I don't know if this has a nice answer. Because I was focused so much on grading the test, I didn't even try these problems. But let's see what happens. Let me see if you guys are cool with this. Do you guys understand what I'm trying to do is to get it like broken down like this? One more, yes? What would every number at the end have to multiply to be? -2. So what kind of numbers could show up here? 2 or 1, yes? Positive or negative, yes? Assuming it's a nice problem, assuming it actually factors. So let me try 1. Why not? And I see that's not going to work, but that's okay. But -1 work, let's see. No. So real quick, I'm sorry, I'm doing it. So bring the 2 down, multiply, add, multiply, add, multiply, add. No. And I think -1 has the same problem. -2, -2, 2, yeah. Okay. So what about 2? 2, 4, 4, 8, no. What about -2? No. Okay. Good job, John. So, great. I should have checked this before. So I've given you a problem you can't do. Yay. Now you could graph this and get the intercepts. Yes? That would be fine, especially if they gave you this problem. Okay. Now it's coming back to me. Yeah, I should have changed this problem. It's okay. It's a good learning experience. Did anything change in terms of what I want to have happen? I want to see where this is undefined or where it equals 0. If I try to equal it 0 and I cannot factor, then synthetic division is a good option. I just forgot to go back and change it so it would actually work. So what would the answer be then? Well, we could graph it. Let's see. If I graph this thing, what is it? 2x cubed plus x minus 2. Yeah. Hey, look at that. It's really close to 1. Now, have you guys ever done this before? If I hit second trace to go to calc, I can calculate the 0. It's going to want a left bound, a right bound. Has anyone ever done this before? And then it's going to want to guess. And I get 0.835. Okay. 0.835. So to come back here, I get x is 0.835. So how do I find the point then that's closest? If I know x, how do I get y? Plug it back in? Yeah. Now, real quick, just to show you physically what's going on here. Can anyone tell me anything about the parabola x squared minus 1? Anything. Tell me anything you know about it.
It's a problem. It opens up.
Huh? Shift it down by 1, so it's going to go through 0, -1. Yes? What are the x intercepts? -1 and 1. Okay, so here it is. And then the point that I was trying to minimize the distance to was the point 2, -1. So I'm trying to get the closest. I want to see this thing is moving like this. I want to see when does it get closest to this. So do you see how it is something around here? This would be further away, yes? That's a farther line, yes? And this would be further away. So somewhere like right here is the closest. And that's basically what we got. We got 0.835, which is right there. I don't know if you guys are really with me. That's what we actually the math we just did was kind of like when you hear about an asteroid. Has anybody ever heard of, there's been several asteroids over the last couple of years that have come, close in astronomical terms to Earth. Have you guys understood this or realized this? You're all like, what? So, if they know the trajectory of the asteroid, they could do this to figure out what its closest approach would be. Yes? If they know the trajectory, and they know, here's Earth, good old Earth, and then they can see what's the closest it's going to be to us. Are you guys kind of with me? Now, of course, that's three-dimensional. It's got a few more things to worry about, but fundamentally, it comes down to this. Yes? How the... Oh, it doesn't change. I need you to understand. If I said the smallest that the square of a number, the smallest that the square of a positive number could be is 16. What's the smallest the number could be? So if I minimize the squared thing, I inherently have minimized the thing. So this wanted me to minimize the distance. Calculus would suck for that. So I said, let me minimize the squared distance, because in doing that, I minimize the distance. Does that make sense? Because it's a same, exactly. I like it. Because x is internal, it's inside the root if you square root it. So finding it doesn't really change anything. Okay. Remember to change that damn problem. Okay. Do you guys want to take an early break? Or is this too early? Or does anyone care? Let's take a break. Nobody's answering me, so I think that's gonna tell me we need a break. So 5, 10, 15, 20. Yeah, come back at 11:35. I'm shooting to have us leave a little early today, so if anyone has a problem with that, just mute yourself. And a little early doesn't mean 12, so don't get too excited. Did anyone not get their quiz?